This is a video on solving systems of equations involving three variables. First, let's talk about the process about solving a system of equations with three variables. First, you want to use elimination to create a system of two new equations, each having the same two variables. And the way we're going to do this is actually by picking out two of the equations and picking a variable to eliminate, and then picking out another set of two equations out of the three and picking a variable to eliminate. We'll see this more in the example. Once you've done that, you have a new system of equations that each has two variables in it. So you can solve that by either elimination or substitution. Once you've solved that system, you can back substitute into the original equations to find the remaining variable or variables that you need. Let's take a look at an example. So we want to solve the system of equations that we have here. 2x minus 3y plus z equals 6, negative 5x plus 2y plus 3z equals 7, and 8x plus y minus 6z equals negative 16. Remember, our goal when trying to solve a system of equations is to try to find the ordered pair, in this case the ordered triple, that works in each of the equations. So when I'm going to solve this system, what I'm really trying to find is the x, y, and z value that works in all three of these equations. That's what we're really looking for when we solve this. And that's why you could check at the end. If your x, y, and z values work in all three, then that means that you found the actual solution. So I'm going to label these equations equation 1, equation 2, and equation 3. And this is just so I can refer to them as we go through the example. And I want to pick a variable to eliminate. And it's up to you which variable you choose to eliminate. In this case, I'm going to choose to eliminate y when I create my two equations. The reason I'm choosing y is because I can see I have a 1 in front of the y as a coefficient down here. You don't see a number in front of it, so there's a 1 there. So I know that I'll be able to eliminate that with the equations above it by multiplying it by some factor. In this case, multiplying it by a negative 2 or a positive 3 will cancel with equation 1 or equation 2. You could also choose to eliminate the variable z here with using equation 1 because the coefficient of z is 1 here. So you could multiply it by a negative 3 to eliminate with equation 2, or multiply it by a positive 6 to eliminate equation 3. But I'm going to choose to eliminate y's. So I want to create two equations with variables that only have x and z in there, so there are no y's in there. So between equation 3 and equation 1, I'm going to use equation 1 and equation 3 here to create my new equation. I need to figure out how to eliminate y's. Well, if I have a negative 3y in equation 1, if I want to cancel it with this y down here, I need this to be a positive 3y, because a positive 3y plus a negative 3y would cancel out. So I'm going to multiply equation 3 by a positive 3. So we're going to multiply equation 3 by a positive 3, then add it to equation 1. So equation 3, we have 8x plus y minus 6z. I'm going to multiply this side by positive 3 is equal to a negative 16 times positive 3. And I would show this on both sides, this way you don't miss anything. We're going to distribute the 3 through. So this is going to be 24x plus 3y, and 3 times a negative 6z is a negative 18z, is equal to negative 16 times 3 is a negative 48. Be very careful with your signs here. It's very easy to make a mistake. So this is like my new equation 3. And the reason we chose multiply by a positive 3, remember, is because I need this to be the opposite sign of the y in front here. So I'm going to add this to my equation 1, which was 2x minus 3y plus z equals 6. We're adding these equations together to form a new equation. This is equation 1 here. So my new equation 3 plus my equation 1 should eliminate y's. That was my goal, remember. 24x plus 2x gives us 26x. Plus 3y minus 3y, they cancel out. They should cancel out because they have the opposite signs and the same coefficient. And then a negative 18z plus z is a negative 17z. And that's equal to a negative 48 plus 6, which is a negative 42. I'm going to call this equation just star here. This is going to be one of my new equations in the system that I'm trying to create. Let's talk about how we would create another equation. So now you want to go back up to our original two equations up here, or original three equations up here, and you want to take another pair of them and also eliminate y. So since I eliminated y's in the first one, I want to eliminate y's in the second one as well. This way my new system only has x's and z's. To eliminate y's, again, I'm going to choose equation 3 and equation 2 because I see the single coefficient of y here is just a 1. And I'm going to multiply equation 3 by a negative 2, so it'll cancel out with the positive 2y I have here in equation 2. So we're going to choose to, eliminate y's still. They have to be the same when you eliminate in both of them. We're going to eliminate y's. We're going to use 2 in equation 3. And I'm going to multiply equation 3 by a negative 2 and then add it to equation 2. This will help us eliminate y's. So equation 3 was 8x plus y minus 6z equals negative 16. And we're going to multiply both sides of this by a negative 2 here. So negative 2 times this side, negative 2 times this side. Make sure you do it to both sides. Negative 2 times a positive 8x makes this a negative 16x. And negative 2 times a positive y makes this a negative 2y. And the negative 2 times a negative 6z makes this positive 12z. This is equal to a negative times negative makes this a positive 32. Alright, be very careful here and watch your signs. If you don't watch your signs, the solutions won't come out correct. So this will be my new equation 3 for the second step. That's what equation 3 became after I multiplied by negative 2. Remember, I wanted to add this to equation 2. And equation 2 was the negative 5x plus 2y plus 3z equals 7. We're adding these equations together. And this was equation 2. Now remember, when you add these, our goal is to eliminate y, so they should cancel out. We have negative 16x plus negative 5x makes that a negative 21x. A negative 2y plus 2y, they cancel out. They have opposite signs with the same coefficient. That's what you need to have happen. Plus 12z plus 3z is a plus 15z. And this is equal to 32 plus 7, which is 39. I'm going to call this equation double star. This is the second equation I need in that new system. So once I have this new system, now I can solve it using either elimination or substitution. So my new system of equations using star and double star is 26x minus 17z equals a negative 42. Remember, that was star. And negative 21x plus 15z equals 39. Alright, and we're going to solve this. Using elimination. So, we've got to pick a variable to eliminate. Now you can pick either one, either x or z. I'm going to pick to eliminate z's. And to do this, remember, you need your coefficients to be the same, except for have opposite signs. So we're going to have negative 17z and a positive 15z. Think of this as kind of trying to find a common denominator. You want the smallest number that 17 and 15 can both go into evenly, and then you want to change these coefficients to that number. The easiest way to go about this is just use, the actual opposite number. So if I have 17z and 15z here, I can multiply 17 by 15 to get the number I need, and down here I can multiply 15 by 17 to get the number I need. But remember, you have to multiply to the whole equation for each of them. So I'm going to eliminate z's. I'm going to multiply star by 15, and I'm going to multiply double star by 17, and then add them to eliminate z's. So that's the process. Realize that the reason I don't have to worry about the negative signs on these when I multiply is that one's got a negative, one's got a positive, so they're already opposite signs, which is what we need. So 15 times the 26x minus 17z is equal to 15 times the negative 42. All right, multiplying both sides of this by 15, that's multiplying 15 to equation star. and that will become, you go through and calculate it, 15 times 26x is 390x. 15 times a negative 17z is a negative 255z, is equal to 15 times negative 42 is negative 630. Alright, we can multiply equation 2 by 17 now. 17 times the negative 21x plus 15z is equal to 17 times, make sure you multiply to both sides, 17 times 39. And we'll distribute 17 through. So 17 times the negative 21x is negative 357x. 17 times a positive 15z is a positive 255z. And that's equal to 17 times 39, which is a 663. Alright, and now we said we were going to add these. Alright, so I took care of multiplying each of them. Now I want to add these together. Realize when I add these, z's should be eliminated. That was our goal, right, to eliminate z's. If z's don't eliminate here, it means that you made an error somewhere. So 390x minus 357x. And don't let these large numbers bother you. They're numbers just like any others. You're going to get 33x. And negative 255z plus 255z, those cancel out. And that's going to be equal to negative 630 plus 663, which comes out to a positive 33. And now to solve for x here, we're going to divide each side by 33. Alright, so we got one equation with one unknown. We know how to solve that. And we get x is equal to just 1. Now don't stop here. You're not finished. Remember, you have to go back and find x, y, and z. So we have x. Now to get y and z, we have to go back to our previous equations. So I can use x equals 1, and I can put it into either equation star or double star, substitute in for 1, or substitute x in as 1, and then find the z value that goes with it. I'll substitute into the first equation here. So we're going to end up having, subbing into, alright, so we're going to sub x equals 1 into star, and we get 26 times 1 minus 17z, because we're trying to find z here, equals negative 42. So we have 26 minus 17z equals negative 42, and you solve this as you normally would. So we're going to subtract 26 from each side, subtract 26 here, these cancel out. Negative 17z is equal to a negative 42 minus 26 makes that a negative 68. Then we're going to divide by a negative 17, divide by a negative 17. These cancel out, and I've got z is equal to a negative over negative makes it positive. 68 divided by 17 is 4. So I got z equals 4. So now I know my x value and I know my z value. So the only value I need now is my y value. So we're going to back sub into one of the originals. So I'll back sub into the first one. Alright, so back sub x equals 1 and z equals 4 into any of the original equations. I'll pick equation 1. And for equation 1 we had, it was 2x minus 3y plus z equals 6, and we're substituting in here, so we're going to have 2 times 1 minus 3y is going to stay 3y plus z is now 4 equals 6. This ends up becoming 2 minus 3y plus 4 equals 6. 2 plus 4, combining like terms on that left side, gives us 6 minus 3y equals 6. To solve for y, remember we have to isolate the y term, so we're going to subtract 6, we get negative 3y equals, well, 6 minus 6 ends up being 0 over here. Cancel on this side. These also cancel out. We have a 0. 0 is a number just like anything else. And to solve for y, divide by negative 3, divide by negative 3. And this gives us y is equal to 0 divided by any number is just 0. So y equals 0. So our solution is, we want to write this in coordinates x comma y comma z. Alright, so it's an ordered triple. Alright, so our solution x comma y comma z is going to be x, which we just found was 1 earlier, y we just found is 0, and z, which is 4, and then that's the answer. Remember, to check this, you would substitute it into all three of the original equations and make sure they all come out true. If even one of them doesn't come out true, it means it's not a good solution. You made an error somewhere. Alright, so here's an example for you to try on your own.